Yeah. Hey guys, people are still joining in, so give us a minutes.
I'll give you a go once I'm done.
Hey guys, thanks for joining us. Welcome to the webinar today. My name is Pru. I'm part of the security solutions team at we45. I'll be moderating this webinar today. Today's webinar is on action-oriented threat modeling using Threat Playbook, which will be presented by our CTO, Abhay Bhargav. So threat modeling is a fairly common term used in the information security and application security circles. However widely as it's known, it's done as an ad hoc activity with little efficiency and effectiveness with respect to rapid development. At we45, we strongly endorse that it should be applied at every stages of application development and at each iterations. The best way to do this is integrate it into your software development lifecycle pipeline. However, as a process, threat modeling has become a very manual approach. So for that, we've developed an open source framework for writing threat modeling as a code. The framework allows teams to capture user stories, mapped to abuser stories, that is mapped to attack models and security cases in YAML files. With the help of test automation frameworks, such as Robot Framework, the Threat Playbook allows product engineering teams and pen testing teams to not only capture the entire workflow, but also trigger security test cases with tools like ZAP, Burp, Nmap, and so on. So anyways, if you have any questions, please type it out in the chat box or use the QA section to post the questions. We'll address them during the QA round. So without further ado, I'll let Bay take over.
Thanks, Puru. Welcome all of you, and I'm very happy to be here with all of you. I'm glad you could join us. Today, as Puru mentioned, we'll be talking about threat modeling as code, or action-oriented threat modeling, as we'd like to call it. This is not a, I mean, threat modeling is something that a lot of you have heard of, I'm sure. This is something that is not new. It's been around for a while. But we see some changes in the way threat models ought to be done versus the way they're already being done. So let's talk about some of these things, and let's talk about a new open source tool that we've released called Threat Playbook that all of you can make use of as well to see how you can deliver action-oriented threat models. So without further ado, let me just get started. This is an introduction of myself. My name is Abhay. I'm the CTO and founder of we45. I head most of the technology initiatives at we45. We have quite a diverse practice, including consulting, training, testing, and we also have a product that I've architected called Orchestron, which does vulnerability correlation and orchestration. So we do a lot of work in the DevSecOps, AppSec automation space. So that's one of our coup d'etats, if you will. And we've also been heavily involved in threat modeling and how you can make threat modeling a part of this DevSecOps process. So that's one of the things I'll be talking about today, and talking about Threat Playbook, which helps you achieve this goal. I also do a lot of training at OWASP events as well as other events. In fact, you can find us at a lot of major industry events happening soon in the summer. We are at Black Hat. We're presenting Threat Playbook at Black Hat. I'm doing a workshop on AppSec automation at DEF CON. And we also have an automation training program in New York on 16th and 17th of August. Right. So moving on, today's session is, we'll start off this way. We'll talk about some of the major issues that we are seeing with threat modeling. I'm quite certain that some of you are seeing these kind of characteristics as well. You're seeing these kind of trends with threat modeling as well. This is quite common. Then we'll talk about as code. One of the things that we'll also delve into today is that DevOps tooling, even security tooling, has really matured quite a bit. We have grown extensively in both these areas. However, threat modeling has been kind of kept out of the loop here, especially because threat modeling is largely seen as a enterprise type of activity. We see that threat modeling is largely kept out of the loop and kept out of the automation part of this, which we feel is wrong. And we'll talk about what we can do to fix it. And one of the reasons why we came up with Threat Playbook was simply to address this big vacuum that we saw in this space, simply because we felt that threat modeling should be done in a much more actionable and much more action-oriented way, and not only as this documentary activity that is performed by most organizations in a very static kind of approach. And then I'll do a demo with Threat Playbook. You'll see some of the Threat Playbook in action, and you'll see how it works and how you can use it. Of course, I encourage all of you to use it and submit some of your feedbacks. We are looking for contributors to add to our existing code as well. So I'm happy to have all of these collaborations going as necessary. Of course, as with demos, I always have to pray to the demo gods for the demos to go well, because as with most demos, there are always things that might go wrong at the last minute. So I'm praying to the demo gods, and hopefully everything should go well. So let's start with some current problems with threat modeling, right? I'm sure, as with a lot of other things in security, there are some specific buggy issues with threat modeling that a lot of us would like to address, but probably have not gotten around to, or probably don't understand how to address it as well. So let's look at some of the key issues that I am seeing and our team has been seeing, especially because we do a lot of threat modeling for clients. We've been seeing some of these issues play out over and over again in a lot of organizations. One of them being that threat modeling is largely performed as an enterprise policy document sort of thing. So it's largely done as a documentary or a checklist item in a lot of organizations, where they just do threat modeling once in 2 years or once a year sometimes. And it's just relegated to the status of a document and stored as part of this amazing large repository of information security documentation that most people don't ever get around to reading for the most part. So this is one of the major issues that I see with the way threat modeling is delivered at a lot of organizations. The other thing that I see with threat modeling is that threat modeling does not really keep pace with the product development lifecycle. Now, any product, even if you are a product company or a company that is developing software that is not so fast-paced, or you don't have very rapid release cycles, chances are that your products are changing quite a bit. Even if it's an internal product, even if you're part of a team that is not doing 5 releases or 10 releases a day, chances are that your products are constantly changing. They're constantly undergoing the changes, you're adding features, removing features, you're doing a lot of stuff with the product. And unfortunately, the threat modeling piece of this is not really keeping up. I have not seen too many organizations do a very good job of threat modeling along with the product development lifecycle. So threat modeling somehow does not keep up with the activity, and security kind of gets left out. I've seen that if you don't do threat modeling with the product development lifecycle, a lot of times you miss out on security flaws. And once you miss out on security flaws at the requirements or the design stage, chances are that these security flaws are going to be much worse moving forward. The other major thing that I've seen is that a lot of threat models are done at a very high level. So in fact, a lot of folks that I've seen using tools, they say that they auto-generate threat models and so on and so forth. A lot of these tools do that. They auto-generate threat models, or people do it with the help of certain tools in the industry, maybe open source, maybe commercial, whatever. But what I've seen is a lot of these tools give you a very high level perspective of threats, which are not very useful to make actionable, right? if these high-level perspectives come up in a threat model, then you don't really know what action you need to take. The developers or your ops folks, your DevOps folks, your security folks don't really know what they need to do with such high-level guidance, like encrypt everything. I mean, something like encrypt everything or do input validation. For instance, these are typically high-level recommendations that are not necessarily useful to anybody simply because they just tell you what to do at 30,000 feet in the air kind of a view, but they don't really give you a detailed view of what needs to be done. And there is not really much collaboration around what needs to actually be done to address that particular threat. So this results in boiling the ocean, right? What happens is that threat modeling is done system-wide against a huge system a lot of times. And when it's done against such a massive system, you always end up getting mediocre or subpar results, mostly in the form of high-level results and not very useful in terms of results. So these are some of the major problems I see. And what makes these problems worse is that they're usually taken up at the beginning as a project and then forgotten or not at all updated or updated very infrequently. It's not integrated with the Agile SDLC. It has no real link with your Agile processes. So you don't really have a direct mapping between your functionality and the threat model against that particular functionality. So it does not really move with your process, does not really move with your life cycle. And a lot of times I've seen this, and this is, I'm sure, a lot of security folks who are in the room today will know this, that threat modeling is largely done, in many cases, by security folks, only by security teams. And this ends up becoming quite one-sided simply because security teams are, while they are good with security, they may not be privy to all of the different types of business risks that are there for the organization, for that particular application. They may not be privy to all of the constraints that the architecture team has or the dev team has or the other teams that are working on this product has. So this makes threat modeling a whole lot worse and does not make it a very effective process, although it can be made much, much more effective. It can be an invaluable addition to your security process. And a lot of times I've seen this, right? A lot of threat models have largely been about generating diagrams. Whenever I talk to somebody doing threat modeling, they are often generating diagrams, creating diagrams either in Visio or some other tool, what have you. And the focus of this process seems to be that they are generating diagrams and not really focusing on the threats. So this is one thing that we wanted to address in our process. I'm not saying generating diagrams is necessarily a bad thing, but I'm saying that that should not be the focus of our threat modeling efforts. Our focus should be, let us identify the most relevant and context-driven threats to our application or our environment and get some results around mitigation, around security testing, around all of that stuff. So that's what we're all about. So as a result of all this, we see oftentimes that threat modeling or any kind of security activity related to threat analysis does not have too much visibility with engineering. So most of the time, threat modeling is overridden by engineering or management that says, you know what, we'll deal with this later. Or the threat model is just said that, oh, you know, lip service is paid to a lot of threat models that say, okay, this is great. Yeah, that's fine. But they would never end up really using it afterwards. On the other hand, we have seen some amazing innovations in the land of DevOps and continuous application delivery and even application security, right? We've seen some amazing innovations around this space. Largely, we have seen the rise of spec-based systems. I call them spec-based systems. You could call them orchestration systems. You could call them whatever you want. But these are the frameworks that require you to just define deployment specifications or delivery specifications or different application parameters as a specification without having to write complex orchestration code. Stuff like Kubernetes or Ansible or Chef or Puppet or what have you, they do not require the user to write complex code. They need you to write specs. You need to write specifications, and these specifications are run as code. So they're kind of like meta-programmed, and code is generated, and containers are deployed, or your servers are deployed, your AWS workloads are provisioned and then deprovisioned, your serverless applications are deployed. So you are really seeing that the as code format of doing things is really about creating specifications. And these are cross-functional specifications. They don't really require you to have an amazing array of knowledge in different programming languages like Go. For instance, Kubernetes is in Go, but you don't need to know Go in order to use Kubernetes. You can figure out how to deploy, how to orchestrate containers, and you can go ahead and write your own Kubernetes YAML files, or even use the kube controller and start running your own deployments. So everything has become as code, and this is becoming a really, really popular movement right now. I'm sure you'll see this amongst your own organizations or within the circles that you follow. So if you look at it by spec, most of these things, and this is just a small cross-section of tools that I would call spec-based tools, right? Ansible, Kubernetes, serverless, CloudFormation. All of these allow you to write specifications, and these specifications are then converted to code and used to deploy your apps or configure something or run a particular task against your application. All of this is really becoming very popular, and this movement is gaining a lot of traction, and I'm seeing a lot of people get involved, large and small organizations get involved. So basically, we have all of this: continuous integration, infrastructure as code, cloud deployments, container orchestration, and even to a certain extent, security as code. However, as always, security is a little bit of a straggler here, and security always lags behind simply because there is not as much effort or as much time and resources dedicated to security tooling. And security tooling, I'm sure whoever has dealt with DevOps or DevSecOps has seen that security tooling is not easy. It's a lot more complex than it initially looks. So security as code, yes, it's still picking up. We're seeing some amazing innovations on the one hand, but we're still seeing stuff like threat modeling and some of the more critical aspects of this being left out of security as code. And that really creates our philosophy, right? And that was really the foundstone of our philosophy, so to speak. We believe these few things when it comes to threat modeling. One, we see threat modeling as playbooks, right? We see them as playbooks to ensure that your application is always one step ahead of the game, or your environment is one step ahead of the game when it comes to security. So if you do a good job of threat modeling, you're constantly evolving as a great security team or a great security program. And this security program, scalable, it's maintainable, and it also moves along with your product development. It does not move, in a different direction, or is not a static aspect. It's not just this one, Bible kind of thing you put down and that is served for centuries and centuries. That doesn't work that way. What we're looking at is evolving playbooks for your product, for your application engineering, because your products are evolving. Naturally, the threats and the threat modeling processes or the threat models also have to evolve. We also believe in collaborative threat modeling simply because without collaboration, you are not really getting the best value from your threat modeling process. Again, I've talked about this before. A lot of threat modeling teams boil the ocean. They do a system-wide or massive threat model against a massive. So let's say you're a core banking application or something like that. Trying to do a threat modeling against something like that is not only complex. I'm not saying it can't be done, but it's extremely complex, time-consuming. And sometimes you spend so much time on it, you get it wrong at the end of it, and it becomes quite useless as a threat model itself. So iterative threat modeling, in my opinion, makes it a whole lot more achievable for teams to get to the value that they want from threat modeling. And all of this makes it a lot more manageable. Of course, one of the things I'm sure a lot of you agree with is the benefits of threat modeling. In my opinion, threat modeling really has a whole host of benefits. In fact, I feel that if you do a good job of threat modeling, you are pretty much achieving massive security values throughout your SDL or throughout your lifecycle, simply because you are able to find and address issues as early as possible. So you're not finding issues when the developer writes it. You're not finding issues when the build is created. You're not finding issues when it goes to production. You are actually finding issues with threat models right at the requirements gathering and design stage, which is the earliest possible point you can find security issues. And if you can do a good job of finding those threats and those potential gotchas when it comes to security, you are ensuring that a lot of the security threats don't even happen. They don't even come to life. So it becomes a very, very powerful process to do a good job of threat modeling, because you are really achieving massive value over your entire life cycle. So it becomes an input for, like I said, mitigation strategies. You can do benchmarking with it. You can use it for static analysis. So let us say you want to check for this authorization. Let us say you have threat model that user should not be able to perform this kind of an authorization bypass. You can use that particular threat model in your static code analysis, feed it into a static code and SAS tool or something like that, and create some kind of a rule for it. Or you can tell your pen testers to say, hey, guys, I want you to pay special attention to authorization bugs because we've threat modeled it. And we've seen that with this particular feature that we're looking at, authorization bugs are big, or crypto bugs are big, or whatever it is. We want you to test those with extensive expertise. So these are the kind of things you can get out of threat modeling. It's not just this document that gives you a list of threats that you should use to mitigate. It's not only for mitigation, but it's also to give your entire security team a sense of coordinated purpose when it comes to the application. So which is why we created Threat Playbook, right? Now, Threat Playbook, of course, I don't think it would be right to say that we've addressed every single aspect of what we're talking about, but we have made an effort to take in a lot of what we saw out there that was bad and try to improve on it and make it better. Of course, I'm sure, as all of you know, that there is nothing perfect in this world. There's always scope for improvement, and we are always looking to improve this. So Threat Playbook is a way that we felt was really useful. We were using this for our customers a lot of times when we did threat models. And Threat Playbook for us kind of evolved from that thought, or that set of thoughts that we had. So when we are engaging, especially for managed services with a lot of our customers, we are part of their application security team. So we realized that if we could threat model right at their requirements gathering stage and include it in their user story or functionality spec as a threat model, that would really serve as a very powerful way of actually identifying and modeling threats. The other thing that we saw was around pen testing. And while pen testing is not a very conventional approach to conventional use case of threat modeling, we at we45 find it invaluable. I'll tell you why. What happens when we do pen testing is that we look at the app, we walk through the app or whatever it is, we identify the app and what it does, and we actually create an attack model, a threat model of sorts, oriented towards mostly the attacks, where we say that, hey, this seems to be a stock trading application. These are the specific risks. This seems to be a corporate expense management application. These are the security risks. We need to look for these the most. We need to look for these probably L2 and these L3 or kind of something like that. We actually prioritize our pen testing based on the attacks that we do. So this Threat Playbook we felt should also address this need of ours, which was essentially how do we orient security testing efforts and threat modeling, and also how do we orient continuous application security with threat modeling. So these were the two problem statements we placed in front of us when we created Threat Playbook. And I'll just get into a little more of what it is. So the Threat Playbook way is essentially like this. So you have a user story. I'm sure a lot of you in the Scrum world who have been part of Scrum teams understand this term. You have user stories or functionalities or a description of the functionality. And then you have something called an abuser story. Now, an abuser story is, like I mentioned here, how that particular functionality or how that particular user story can be abused. So let us say let's say I'm threat modeling a corporate expense management app. That's the example I'm going to be using today. And one of the user stories is that the manager can approve colleague's expense after reviewing it and get that expense reimbursed to that particular colleague. Now that is the user story. So as the user story would typically read, as a manager, I would approve my subordinate's expense so that my subordinate can get reimbursed for legitimate business expenses. Now, this is the functionality. Obviously, functionality can be abused, and that's what we've seen with security attacks all over the world. And in this case, one of the abuser stories could be, as a malicious employee, I would try and approve my own expenses. I would try and approve expenses that I create so that I can bypass the whole approvals process and approve them as my manager. So I could do that is an abuse. That is one example of how that functionality could be abused. As you can see, that's a pretty high level statement. So that is an example of how that functionality could be abused. Now, how does that actually happen? This is the what. So abuser story really addresses the what part of the equation. It says, as a malicious employee, I would try and approve my own expenses so that I can raise bogus expenses, right? Now, this is the what part of it. Now, the how is actually your threat scenario or the threat model, right? I could steal my manager's password, or I could, do a man in the middle on the manager's tokens, or I could try and do some kind of a privilege escalation attack in the application to approve the expenditure. I could do all of these different things. And all of these different things have different approaches to mitigating them. So as you can see, we have created the user story, the abuser story, the scenario or the model. And then we also have two additional segues from this. We have the security test case, which is essentially how does somebody test for this? So what are the different testing approaches somebody adopts for this particular vulnerability or this particular threat scenario to come to life? And then, of course, how does somebody protect against this? This is the mitigation. So as you can see, in these 5 steps, you really have all that you need from the threat modeling perspective. Obviously, this is what I'm presenting is a relatively simplistic perspective. You do have different models, you have different approaches to this. We're not saying that this is the best way to do it. We use whatever worked for us, and we feel that it will work for a lot of other people as well. And that is the approach that we are using in Threat Playbook as well. So if you look at Threat Playbook, the orientation is like this, the approach is like this. So essentially, you build a threat model, you create your user stories or your functionality specifications, you create abuser stories if you want. Again, Threat Playbook does not force you into any workflow. You don't have to create abuser stories. So let's say you have user stories and you directly want to jump to threat scenarios, you can. You don't have to create abuser stories. Abuser stories is just another step towards achieving a more complete threat model is what we feel. So you create threat scenarios, right? From these threat scenarios, what you can do is document security test cases. Now, I'll show you what a security test case looks like in Threat Playbook, and you'll see how it works and how it is to be written. Now, these security test cases would tell you how you would test for that threat scenario. So let us say I would look for injection flaws to perform this. So let us say the same approval example, I would do a SQL injection and gain access to the database and approve my expenses, right? That is a SQL injection attack. So I would document that as a security test case to say that SQL injection attack against this particular abuser story. And then I would test for SQL injection with a ZAP, a burp. I would also do a manual set of tests. I would do a bunch of other checks. Let us say I'm doing it internally as well. I would check for database hardening. I would check for maybe the WAF rules, et cetera, et cetera. I would build my test cases against that. And in some cases, one of the things that we also introduced was the ability to automate some of these test cases. And this is where the whole DevOpsification of threat modeling really comes in, because what we are trying to build is a system where you can start off from threat modeling and actually create a security test case, run security tests against all of these, and then map this back, right? So what you can do is once, let us say you run ZAP and burp in an automated way against these particular threat, against your application, and they identify SQL injection. Now you know that your threat models are actually, they have validity, because you can say that, oh, I've identified SQL injection. SQL injection was part of these many threat scenarios or these many abuser stories, right? So automatically you have a coverage between threat modeling and automation, and vulnerabilities, which is a huge change from what we have seen in the industry at large, simply because a lot of times, a lot of customers ask us, hey, what is the coverage of your pen test? What are you testing against? And unlike the functionality world or the performance world, we don't really have a lot of these metrics mapped out prior, right? In security, I would say that our coverage should be against a good threat model. And that's what we're doing here. So we're saying that, look, you can invoke strategic automation against these security test cases, and then they would try and map out this automation versus what has actually been identified, right? So this is really giving us our whole DevOps flavor of things, right? If you are in a CI/CD pipeline, you can run this as a complete security pipeline. So you can document your threats. Since this is an iterative process and you're capturing it as code, you can check it into a GitHub repo. You can run this as an automated process, and it would, first of all, generate all the threats. Then it would run all the tools, identify the vulnerabilities, and then generate reports against those threat models and those vulnerabilities that is identified. So it really gives you that entire security pipeline effect that you want in your CI/CD pipeline. From a pen testing perspective, it gives you value as well, simply because as a pen tester, you can automate a lot of these processes. You can automate the running of vulnerability scanning tools. You can automate the running of some of the other tools that you want. You can create a pen test pipeline of sorts. In fact, that's something I'm going to be talking about in my trainings as well as the DEF CON workshop that I'll be doing. How do you create both these different types of pipelines, and what do both these different types of pipelines mean? So we're really building a massive case for automation when it comes to threat modeling, and we're actually creating a mapping between the threats and the vulnerabilities identified. So the process with Threat Playbook is you write out your threat models in YAML files, just like you would write in Kubernetes or Ansible or many other frameworks. It's iterative and modular, so you can create models with different type of, so you can create one functionality per YAML file. You don't have to stuff everything into one massive spec. You can create different functionalities in different files, and this can be individual. So let us say that functionality undergoes a small change. You can always quickly make changes to your YAML spec that has that particular threat model. So you can actually iterate. That is the idea of creating this with specification files. And you can also link it to security test cases, because if you choose to link it to security test cases, you're going to get that whole reverse mapping between vulnerabilities identified and the security test cases run. You can also run automation with this. I'm going to show you an example where I'll run a fully automated security pipeline with my threat models, and it generates reports and tries to map it back to those very threat models, right? So who can use Threat Playbooks? Right now, we believe that these two teams will get a lot of value from Threat Playbook. Engineering teams, because you can run, develop, and scale iterative threat models. You can run a security pipeline with threat modeling included. So apart from just running your automation tools, you can also include threat modeling as part of that automation lifecycle. Right? Pentesting teams can also run this. You can create attack-driven threat models, and that will help you also hone your process of security testing as part of your pen test as well. So without further ado, I'm going to do a demo for you guys. I'm going to talk you through how this works, why this works the way it works, and you'll see for yourself our approach and our, our perspective of threat modeling as code. Let me quickly open up the files for you. Now, as soon as you run Threat Playbook, it automatically creates a bunch of boilerplate code for you. You don't have to do, as soon as you do Threat Playbook and you give it a name of a project, it will actually create boilerplate code for you. It creates these folders. For instance, it creates the cases folder, the entities folder, the security test folder, the results folder, as well as it just creates a robot script. Now, we are going to be using robot framework for the automation part, but the threat modeling part can be captured without automation as well. If you don't want automation, you can just capture it as threat models as well. So let's talk. Let me talk you through some of these, some of these entities and some of the things that they do. So first, I want to talk about the entities, and this is what is usually used to create the process flow of the application. So this is the entities YAML file. As you can see, it is a simple file. It's not, doesn't really have any code, so to speak. It's just a simple YAML spec. You have different entities. Now, these are the entities that form parts or features of your application. So let us say a user can access the login functionality and do this, and then can do this, and then can do this, and what have you, right? Now, the reason we have entities and entity connections is that Threat Playbook actually generates a process flow diagram for you at the end of the whole thing. You can actually generate an automated process flow diagram with Threat Playbook without having to actually diagram anything. So one of the things that I hated doing when we were creating Threat Playbook was writing or creating Visio diagrams by drag and drop. So this was, we wanted to do it by code, and this does it by generating those diagrams automatically for you, right? So here we have the user logs in, and from the login, the user can connect to these, can manage expenses or approve expense or view user profile. So what I'm going to be showing you is a demo of a corporate expense management app. So where, employees can log their business expenses and somebody can approve and get reimbursed for it. So that's the simple app that we have. It's an intentionally vulnerable Node.js app. So I'm going to be showing you the demo with this. So this is essentially the manage expenses part of it, where, the view for expenses, this is for a particular user. This connects to two other views, which is create expense, delete expense. So this is create expense, delete expense. And there is an S3 scenario also where, you can use that to upload certain. So whenever you're creating an expense, a user can upload receipts, and these receipts are stored in an Amazon S3 bucket. Of course, you can do approve, you can do view user profile, you can do a bunch of other entities. All of these entities that you have in your application can be mapped out to this in this particular YAML file. The next thing that I'm going to be showing you is the cases directory. And in this directory, you can capture each feature that you want to threat model as a separate file. So in this case, I've captured only the login feature as a separate feature, and I've threat modeled only that login feature. So you can see I've given it a user story. As an employee of the organization, I would like to log in to WFuzz ZAP to manage my expenses and reimbursements. That is the simple user story or functionality description of that particular feature, right? And then you have the abuse cases or the abuse stories, abuser stories, if you will. So each of this has a unique name. So in this case, it will be external attacker, account takeover, end user, this would be one abuse case, and these would have different threat scenarios. So the abuse case, I've captured only one in this case. It doesn't have a full-fledged threat model yet. As an external attacker, I would compromise multiple user accounts to gain access to sensitive customer information, right? So this would be, I would do it, and then I capture the threat scenarios. How would this abuser story actually come to light? This would be through probably injection or RC style attacks. And then I write out security test cases in which I'm going to run against those, and the severity. So severity 3 is the highest severity. You have 3, 2, 1, and 0. End user weak password, which is I would try and defeat authentication by brute forcing passwords, or I would try and hijack the authentication token or authorization token. I would try and do a cross-site scripting to hijack the token. I would try and do a generic auth bypass. These are the ways in which we would be trying, or an attacker would typically try to compromise our application. So we kind of map these out. Obviously, this is not a fully complete threat model. I'm just giving you a flavor of how this works. Same with this feature. So this feature is actually the one I mentioned before, which is approve expense, right? In this case, as a manager, I would review and approve expense of colleagues based on evidence of them incurring the expense, right? Here I have an abuse case, which is employee create and approve the expense. So in this case, as an employee, I would get my own expenses approved so that I can, I can steal a bunch of money from my organization. So bogus expenses I can get approved. So I could do an injection attack. I could try and exploit the manager's weak password. I could do a token hijacking. I could do another type of the XSS. A lot of these things, as you can see, can be reused, right? If you have, there will definitely be a lot of overlap between certain features, one between the other. You can also reuse. The idea of using it as code is that you can reuse this and not necessarily always have to create it from afresh all the time. So then you also have a privilege escalation where somebody tries to do, an IDOR or some other type of direct object reference or mass assignment style attack in order to approve the expense, right? So that is something that we've done. And we have another feature as well, which is the manage expenses. I'm not going to get into that because I think I've given a gist of how you can structure these tests. Now, one of the things, none of these are forcefully rendered fields. So in the sense that if you don't want a severity, if you don't know what is the common weakness enumeration ID of that particular flaw, you don't have to enter it. When you enter it, it just makes it richer simply because we correlate by this ID, right? If you give the right ID and maybe ZAP finds a vulnerability with this ID, they would both be correlated, and it would tell you that, hey, your threat maps against a vulnerability that you have within your own application. So it just makes it a richer, more complete experience. None of these are forcefully required to be entered. It's very, very optional. In fact, even the cases, you don't have to map the security test cases if you don't want. You just want to use this purely as a threat modeling as code piece. You can use that. You don't need to do anything else. Same with, then you have security tests where you can capture a whole host of security test cases that you want. Now, security tests are typically, they have a description, they have a type, which is automated security test, whether you're going to run a tool or whether you're going to do this manually or whether it's a recon, what kind of a security test is it? And it also has tags. So one of the things these tags do is that when you run ZAP in an automated fashion, and if it finds a security test with this tag, it would automatically link it to that. So that becomes a very powerful way of linking the tools you're using or the techniques you're using against the actual, the tool you're running. So that becomes a very powerful way of linking some of this. So Burp or Arachne. So we have a lot of integrations. If you look at we45's GitHub, the public GitHub, you would see a bunch of integrations with different tools that you can use for this. We have tools that we're integrating with all the time. We have the popular ones we already have integrations with. So this is our entire threat modeling piece that I'm talking about. Now, all of this is brought together in this robot file. And I'll talk about this robot file in a bit. Now, this robot file, we are actually running a full-fledged pipeline. So what we're doing is we are running a pipeline. So what we're doing is we're pulling code from Git, from our GitHub repo. In this case, it's the Node.js app. Then we are also running Node.js scan against this, where it is a SaaS tool called Node.js scan. And then we're storing the results in a database for parsing and analysis. We're also running npm audit, which is a source composition scan. It actually examines the package.json file in Node in the Node source code and identifies vulnerable libraries against it. It also does a basic SSL test. Then it runs ZAP. Now, one of the things that we're doing with ZAP is we're running, if you've seen our other security automation webinars or trainings, you would see that we run authenticated scans. So it actually authenticates. This is a web service. We authenticate to the web service. We do one or two things with the web service. We just access a few functionalities, and then we run a full ZAP active scan against it. And then the other interesting thing that I've done is actually written a custom exploit. So one of the exploits that I have today is one where I approve my own expense through a insecure direct object reference mass assignment style attack, where I can tamper with one of the parameters and that approves the expense as a user itself. Now, this obviously cannot be, ZAP does not have a rule for this, for instance. So I have to write a custom regression script. So I have a pen tester, I found this, I have a custom regression script that I write. I can actually load this regression script and include that in my entire piece. So initially it loads the threat model, all the entity files, the cases files and stuff. It loads all of these files with these tests, and then it starts your automation process. At the end of it, it should generate a nice little report for us and generate a lot of diagrams that all of us find. So, I mean, we need from a threat modeling perspective, but we don't actually have to sit and draw ourselves in this case. So let me just run this. So this is our Node.js app. I'm just going to quickly restart it. And I'm just going to make sure that we don't have, yeah, so we're okay on that. I'm going to run this and so this should start loading our entities. And as you can see, it is not a forced process. Whatever security test it can link, it does, otherwise it doesn't. It clones the repo from GitHub, runs Node.js Scanner, which is a SaaS tool, open source SaaS tool for Node.js. It runs npm audit against the package.json file. It runs a test SSL testing process against this. Then, of course, as you can see in the background, ZAP is started up. This could be ZAP, it could be Burp, it could be Arachne, it could be most of the other tools that you could use. We largely like using some of these tools, particularly 3 of these tools. So I've started ZAP, then I'm going to authenticate to my web service, as you can see, and I'm going to start running a ZAP active scan pretty soon. It should find one major flaw against this application. I'm going to kind of hurry this through, if you don't mind, because I don't want all of you staring at my screen forever and ever. Sometimes ZAP tends to take a little more time on certain types of tests. So in this case, I think it should find a SQL injection flaw soon enough. Yeah, I think it did. I'm going to hurry it along. And yeah, that's, yeah. So ZAP should be showing 100% thing right about now. Yeah, I think it's still running a few payloads for the advanced SQL injection. It should stop soon. So as you can see, you are running a full-fledged security pipeline. You're not just running one tool or something in isolation. You are actually running a SaaS source composition analysis. You're running a DAST. You're also generating a report. You're also doing threat modeling. So that's the great thing about this, because you can iteratively run this as a complete process all the time. Now, this has generated a report, and it's also generated what I like to call threat maps. And I'll show you how these threat maps look and how they work. So all of this has been stored in our results directory. As you can see, these are all the individual scan results from each of the tools. So this is the Node.js scan results, npm audit. This is the ZAP result. This is SSLIs. All of it is written into a report, which is a markdown report. And this also is stored in our MongoDB database, the backend, just for us to. So since it's iterative, you can use this as a continuous process. So you can keep adding features, adding tests, and it would all be stored in the MongoDB in a create or a find or create kind of a basis. So let me just quickly take you through the report. And I'm gonna reveal this in the Finder, open it with my Markdown reader, and you can see what I was talking about, right? Our entity diagram that we created, right, has now been converted into a process flow diagram of sorts. Some of the words are cut out, but you can always tweak that as required. But this is a simple example of a process flow. It may not be exactly perfect for what you need, but it gives you a good perspective of the process flow. You also get a detailed description of all the threat models, the abuse cases, and the test cases linked to those if you have linked the tests. And you can see a list of these threat models. I've not captured all of them, but I've captured a large number of them. And then you actually have the vulnerabilities. And wherever there's a CWE and your your abuse case or your threat scenario has a CWE, it will try and link it. So I'll show you what I mean by that. You can see that Node.js scan, for instance, does not have a CWE. So that's why it's not able to link it. Otherwise, it would have definitely linked it. But nevertheless, you should be able to see this with ZAP because ZAP gives you CWE. And this is what I'm talking about, right? ZAP gives you that you have SQL injection, CWE89, and it says that this is linked to 2 of these different threat models, which is great because now you actually have a validation that your process is working because you have the threat model, you also find vulnerabilities against it, which means the risk is automatically that much more elevated for that particular threat model that you have, right? So you have all of these captured as part of your process. You don't really have to do anything separately to run some of the stuff. So this is the report it generates. And the other thing that I was talking about was the threat maps. Now, each of these cases, right, they are presented like this. Now, one of the ways that I thought it would help people is to also visualize this as a threat map of sorts. So where I would have the use case, the abuse cases, and the different threat scenarios and the security tests mapped out as a diagrammatic approach, right? So you can see that each of this is mapped out as a diagrammatic representation. And some of them are more complex than the others. I think this is the more, not this one, I think this is the most complex one we have. So you have a lot of these mappings. Of course, I'm sure some of you would see that we need some improvements in some of these things, and I'm definitely working on it. Our team is also working on a lot of changes to this. But the idea is to have more features, especially, and add more mitigation-specific features to this as well. So as you can see, the idea, let me just come back to my presentation. The idea is to go from threat modeling, capture it as an action-oriented object and not something that is just static or done as a process or done as a, created as a document and left. We wanted to make it more action-driven and action-oriented. We wanted to make it iterative. So that's why we've come up with Threat Playbook. As I mentioned before, Threat Playbook is completely open source. So please feel free to use it. You should find links on, when we release this video, you should find links as well in that video as to how you can use it. And we do have documentation and we are working on improving this quite a bit. So our objective was to try and make sure that threat modeling is iterative, it's more actionable, and it's also very, very friendly to integrate with a DevOps lifecycle or with an automated pen testing or an automated vulnerability scanning sort of an approach. So of course, this is where you can find us. I am at Black Hat. Our colleague and I are at Black Hat. We're at DEF CON as well. And if you'd like to register for our training, we have training in New York on 16th and 17th. So with that, I would like to conclude my presentation. I hope you found it useful. I'll be happy to take questions, if any.
Thanks, Abhay, for that kick-ass webinar. Guys, we have received some questions, so we'll address this one at a time. To start off, how easily does Threat Playbook integrate into QA regression cycles?
Sure. Sorry about that. Yeah, so in fact, Threat Playbook is very friendly to integrate with QA because the reason is that in QA, you have test automation that is written in a lot of cases, right? So when you have test automation created, you can merge test automation with security testing. So what I did with the ZAP example, as you see, is kind of what I did with QA. So what I did was I actually had a test automation script that would run this particular set of commands or this particular REST API call and that would integrate as part of my ZAP scanning process, or do an authenticated scan as part of ZAP. So it's very, very friendly to integrate, especially because it uses Robot Framework, and Robot Framework has a lot of libraries for Selenium, REST API testing, and so on.
All right, so the next question is, how does Threat Playbook compare with other threat modeling tools like Threat Modeler or Iris Risk?
To be honest, I have not looked at some of these tools in a great deal of detail. Yes, a lot of these tools do some level of, I think, in my opinion, I'm not sure about the exact nature of the tools and what they do, but some of these tools, they do offer, I think, more, I would say, pre-made threat models. They do offer a lot of comprehensive threat models for different things, but I'm not sure if they offer the automation aspect as that we have done. I think Threat Modeler is largely a visual tool where you create visual threat models. I'm not too sure about Iris Risk, to be honest.
Okay, the next question is, if we have a threat modeling practice in place already, will it make things easier to migrate to Threat Playbook, or do you suggest we start from the scratch?
I don't think you need to start from the scratch. You can migrate because it's a very spec-like thing, and you can easily, since the code is available, you can easily manipulate it any which way you want. So I don't think you need to start from scratch again, but you need to be iterative. So it's always better to be iterative rather than take on this massive effort.
Is there a template to be used in order to automate our own tools to integrate with Threat Playbook?
You need to use Robot Framework. Typically, that is what we've used for the automation part. But Robot is very easy to use, and we've seen that Robot has a lot of QA libraries that you can use as well.
Okay, so our last question is, will CI tools be necessary for Threat Playbook in order to schedule running of threat recipes for regular runs?
Yes, I do have the similar question coming from a member of the audience as well. His question is it easy to integrate Threat Playbook with CI/CD pipeline as GitLab or Jenkins? What do you think about the time it takes to run security tests within the pipeline? Is that a problem for integration? Now, this is a very good question and one of the most important questions in security automation. Yes, the first part of the answer question is yes, you can integrate this with any CI/CD pipeline. Since we're using Robot Framework, Robot Framework can be run. It does have a Jenkins plugin. I think by default, I think it comes with a Jenkins plugin. Even with GitLab or any other tool, it's very easy. It's just like a shell command, so you can run it. You just need the right Python environment to run it. It's very easy to run. We've integrated this in tons of CI/CD pipelines. So that is the first part. The second part of the question is, what do you think about the time taken? Yes, security tests, depending upon the kind of tools you use, the kind of tests you run, can take more or less time. Let me address some of those specific issues. For instance, some SaaS tools, I've seen that a lot of commercial SaaS tools, they take a really long time to run. Whereas some of the more, I've seen some of the smaller, the more open source, or even the smaller commercial SaaS tools run it very quickly. As you can see with Node.js Scan, it ran very quickly in our pipeline. It ran against, I wouldn't say a huge code base, but a relatively medium-sized, I would say, code base. So it depends upon the tool, how much you're running it against. DAS tools generally take a little more time. Of course, if you can tweak the scan policy and the scan thresholds and this attack strength and so on and so forth, you can get some speed benefits. You can do some DAS tools are a little faster. For instance, Burp, I would say in some cases is a little faster than ZAP. However, I've always noticed that if you use QA automation to ensure that you're instead of spidering, I've seen that it's much faster than running DAST as well. So it really depends on a lot of factors. But yeah, I mean, it really depends upon how much time you want to run the job. A lot of times I feel that having separate security pipelines also makes a big difference because you're not really blocking the original CI/CD pipeline. That has also worked for a lot of customers that we work with as well.
Okay, one of the guys asked of where the GitHub repo is. So I submitted the link on the chat group, but you can always find it by Googling Threat Playbook and we45. It should be easy. Anyways, thanks guys for joining us. Thanks, Abhay, for the great webinar again. So we're conducting a workshop on AppSec automation masterclass in New York City on August 15th and 16th and 17th. It's a 2-day hands-on program that covers practical techniques to get started with security automation. The program will also cover the concept of security as a code with hands-on exercises on creating exploit as code scripts to build security regression. So if you guys are in the area and are interested, please join us. This webinar was recorded and it will be available by next week, and you should receive this in your email. That's it, folks. Thanks for joining us and have a pleasant day.